Hi, good afternoon, everybody. And thank you so much for taking the time of a topic which is a big passion for me, and I hope you feel the same. The objective of my talk today is to talk about the criticality of artificial intelligence required for the design of the next generation network for the next decade. The core networks as we know them today were designed more than 10 to 15 years ago. Everything around the core network has changed. The number of users connecting to the network, the number of things connecting to the network, the number of applications connecting to the network. However, the network is still the old network we designed 10 to 15 years back. Artificial intelligence is now critical to make sure that this network can serve the people, the things, and the applications which are connecting to it. Before I go deeper into the criticality of AI for the network, I thought it would be good to give a very short primer on artificial intelligence. In very simple terms, the most non-technical definition of artificial intelligence is to make a machine think like a human being. Artificial intelligence is not a new concept. It was there more than 60 years ago. Artificial intelligence has two fundamental categories. One is pure AI, where you make the machine really get emotions like a human being, the perception like a human being. And that is where the issue of ethics for artificial intelligence comes into play. Because do you want a world where a machine can start thinking like you, or maybe even better than you? Okay. The second category of artificial intelligence is called Pragmatic AI. This is the artificial intelligence technique which is leveraged by chatbots and by robots as we know them today. Okay. There are many techniques for artificial intelligence. And a current well-known technique is machine learning. In machine learning, you give or train a machine with lots of data for it to make decisions. And hence, sometimes machine learning is called data-driven AI. Contrary to data-driven AI, there was another popular concept called expert systems, which was about making the machine understand rules to make decisions. And that was called rule-based artificial intelligence. A prime example of rules-based artificial intelligence was Deep Blue, the chess play from IBM, if you remember. Okay. Now, machine learning has many models. And a very popular model now is deep learning. Deep learning is fundamentally a neural network model. In very simple terms, for deep learning to work, it needs huge amounts of data and immense elastic compute. And that is why you saw recently a popularity of GPUs to take care of deep learning models. But as artificial intelligence has evolved into many buzzwords, one thing has not changed. For an artificial intelligence engine to make good decisions, it needs two things: lots of data and lots of compute. Now, after giving you a quick update or a primer on artificial intelligence, I'm now going to talk about some tests which were done on the efficacy of artificial intelligence. What you're seeing on the picture here is a picture of a dog and a picture of a bagel. You'll be surprised if I showed you this picture in multiple ways, how often you will not be able to differentiate between a dog and a bagel. However, an artificial intelligence engine for image recognition, you can see the results. The first picture of a dog, 97% of the time it recognized it as a dog. And on the bagel, 89% of the time it recognized it as a bagel. There are many examples like this. If I was to compare an animal, a sheep, with a broom which you use to clean the house, and if I put them together, you will again have problems differentiating between a sheep and a broom as a human being. But an AI engine will not have that problem. But the AI engine still has a long way to go. As I said, what is critical is data and compute. I'll give you another example of a stop sign, a traffic sign which says stop. As a human being, if you're a good driver, when you come to the stop sign, you actually stop your car. Now, imagine an AI engine. If the AI engine does not get the right amount of pixels, the stop sign could appear as a turn sign. Now imagine a car using AI, instead of stopping, takes a turn. That could be a really bad consequence. So again, for artificial intelligence to work, data and compute are two critical items. Now, let's talk about the applicability of artificial intelligence to network IT. Some of the trends which are driving the applicability of artificial intelligence to IT is number one, huge increase in the number of users and things connecting to the network. They're not in millions, they're not in billions, they're going to be in trillions. Second is, as more and more users and things are connecting to the network, network IT still does not have an understanding of the end user experience in connecting to the network. How many times have we experienced a situation where I'm connected to the Wi-Fi network, but I cannot pass any traffic? Okay. Last but not the least, as new standards evolve, like in Wi-Fi, 802.11ax, or called Wi-Fi 6 has evolved, the complexity of designing the networks has gone up, which means it is very difficult to manually, by a human being, optimize this network. At the same time, as the demands of the network increase, the top IT challenges need to be solved. What are some of the top IT challenges? We always hear there are never enough people. Or if there are people, they don't have the right skills. If you have people and you have skills, you don't have the capacity in your network to serve the demand of the application. If you have the people, you have the skills, you have the capacity, then the line of business comes to network IT and says, you're moving too slow. I want this application to be deployed yesterday, and you're telling me it's going to take me another year. And last but not the least, the businesses are pushing network IT to become relevant to the business. At MIST, we recognized these problems. We saw the trends which were coming for the network, and we fundamentally also saw the challenges which the network IT was facing. And at MIST in 2014, when we founded the company, we came out with a vision of AI for IT, or an AI-driven enterprise. If you think about this picture which I am showing, it's a very simple picture. You have an access point which is wireless, which is connected to a wired network, which is then connected to a router, which goes over to the WAN to the application. And then you have firewalls for security. And all of this can be managed today and offered to you by a managed service provider such as SoftBank themselves. But herein lies the problem. Each of these network elements, the switch, the router, and the access point, are standalone siloed boxes. However, you as a user, when you make a connection on a Wi-Fi network, it does not stop just at the access point. The packet goes from the access point to the switch, to the router, to the WAN, to the application. Which means the whole network has to offer a single holistic view and provide insights to what is important to network IT, which is end user experience. But it is very difficult if you start looking at this whole network. You have to design the network model in such a way that, again, the two things come into play. You can get the right amounts of data for insights, and you can get the right amount of compute to program this network. At MIST, this is the challenge we took. As a sidebar, on 1st of April of 2019, we as MIST were acquired by Juniper Networks. This combination of MIST and Juniper has given MIST the ability to now bring this whole AI-driven network to the market. Let me now give you the journey which was required by MIST to give or deliver this AI-driven enterprise. What you're seeing here is the true journey as how MIST today has become recognized as the only AI-driven network in the world. This journey started in 2014. In 2014, the first thing which we did is to understand the data, organization, and telemetry in a network. And to do that, we even made our own hardware. Many people called us not doing the right thing by building hardware in 2014. They said there are so many companies which build hardware. Why are you doing this? The reason was simple. We needed the right type of data. And for that right type of data, you needed the right hardware. So in 2014, we focused on data. In 2015, we came out with a data organization. And in 2016, we structured the data into what was called AI primitives. And I will actually give you a demonstration of this whole journey so that it makes it easier for you to understand. So from data, we structured the data into what we call artificial intelligence primitives. On these artificial intelligence primitives, in 2017, we applied data science models, LSTM, reinforced machine learning, unsupervised machine learning technologies, Bayesian, mutual information, to fundamentally start understanding an issue which could be happening in the network. To make it easy for people to understand these models, in 2018, we introduced the network's first virtual assistant, where you could go to MIST and literally ask or type your question and say, MIST AI engine, which is Marvis, what is wrong with the network? And it will tell you the answer. We did not stop there. In 2019, we introduced the concept of a self-driving network, where the network is now taking decision on its own to ensure optimum user experience. I know it is late afternoon, and I'm giving you a very heavy concept of artificial intelligence. So let me make it a bit more real to understand. What you will see is the world's first AI-driven network. I'm going to demonstrate that to you. And because I only have less time, if you want to get more details, you can go to the exhibition floor and go to the Juniper booth, and you can see the same demo in more details. So here is the dashboard of an AI-driven network. It is very different from a dashboard which you normally see for networking. This doesn't talk about access points. It does not talk about switches. It does not talk about routers. It talks about end user experience. So if you look at this dashboard, how did we come about it? We spoke to many large enterprises, Fortune 1, Fortune 2, Fortune 8, Fortune 10, as to what are the real issues on a network. I was expecting a long list. You'll be surprised. They said there are only 2 issues on a wireless network. I'm unable to connect, or Wi-Fi sucks, which means euphemism for bad performance. We took those 2 and came out with AI primitives. Time to connect and successful connects was an AI primitive which was measuring connection time to the Wi-Fi network, whether you're able to connect or not, and if yes, how long. Roaming, throughput, coverage, capacity, AP uptime started measuring the performance of the network. Then every 2 seconds, Marvis was collecting this information, looking at what is happening to your AI primitives. And then using mutual information or Bayesian was looking at whether the problem is with a certain device operating system, with a device type, and who is getting impacted with that issue. Once we deployed the models, like I told you, we went to Marvis and started asking questions. What is wrong with my Apple Watch in the last 7 days? And Marvis started answering the question. Here it shows everything is okay, but the issue is just on the RF. And then it can start telling you what those issues are. You could also ask a very simple question. Tell me all the unhappy users on my network. And Marvis answered, currently there are 2 users on your network who are unhappy with the network performance. So if you look at this journey, I spoke about data. Then I showed you the AI primitives, time to connect, successful connect, coverage, and others. Then I demonstrated to you how mutual information and Bayesian could be used to try to arrive at what problem is happening on the network. Then we also demonstrated the virtual network assistant. If you think about the things which I showed you in a very 2-minute demo, I ask you to, when you go back to work, think about it. Do you think today your network IT knows your experience on the network? Do you think today there is one system in your enterprise where you can go and ask, tell me the unhappy users on my network? You will find out that the only way this can be answered is through artificial intelligence. So the benefits of an AI-driven wireless network is it gives you the ability to understand end-user experience. It gives you the ability to understand user behavior. And while doing all this, it reduces the cost of the network because of automation. So artificial intelligence, why it has become critical for the network is it gives you the view to end user experience at reduced cost. Now I would like to demonstrate another aspect of an AI-driven wireless network. If you think about it, location is something which is used a lot. If you're using Google Maps or any mapping technology which you like to use for your directions, it is very important that the blue dot is accurate. However, for Wi-Fi location, blue dot accuracy has always been a big problem. There are two fundamental problems. One, Wi-Fi, even though you are sitting here, Wi-Fi will show you you're sitting 15 meters away in a different keynote. Second problem with today's location-based technologies is latency. The blue dot is 10 seconds behind where you are. Can you imagine you're going to an airport and you want to go to gate E12 and you've already passed gate E12 and after 12 seconds it tells you are at gate E12. MIST, using unsupervised machine learning and a patented technology called virtual Bluetooth, has solved both the problems. It offers you location accuracy between 1 and 3 meters and sub-second latency. I'm now going to demonstrate to you a real live network video where I have taken out the name of the customer to protect confidentiality. But what you're seeing here is the mobile app of that customer's enterprise. So when you walk into this customer's location, this is the app which comes up. And now, let us see how MIST is able to deliver on this use case. This person wants to go to the business center. You can see the blue dot on the mobile app. You see the video of the person in the middle, and you're seeing the back-end information at MIST. So see the blue dot, you see this person, and you're seeing information in the MIST network. Notice as the blue dot approaches a turn, look at the latency. That is exactly when the turn is happening. This is all happening again because of unsupervised machine learning. And as the user comes close to the business center, you can clearly see that the blue dot is representing what is happening in the real world scenario. With location, with this blue dot accuracy, many use cases now open up for you in the network. I'll give you an example of a hospital which is deploying this technology. That hospital has a lot of people who have loss of memory or have Alzheimer's. The hospital has tagged the patient with a low energy Bluetooth or a BLE tag. Now, for the first time, as the patient leaves the room accidentally, because they don't know what they're doing sometimes, the MIST system is able to locate the patient and notify the nurse. The second use case, very simple use case, but very, very powerful, is what we call sometimes in the US the E911 situation. If you see, an employee always has two things on him or her: the mobile phone and the company employee badge. More and more enterprises are enabling that employee badge as a BLE badge. So if a natural disaster was to happen, like earthquakes in California, or now fires, or some other unfortunate natural hazard, when people are evacuating the building, the emergency response team knows who is left in the building and where they are, based on their phone or based on their BLE tag. So I hope with this demonstration and with a primer on artificial intelligence, I have given you a thought about why an AI-driven enterprise is important. I am now going to talk about two use cases or two real scenarios which happened to some of the biggest companies, global companies. First use case scenario was a big retailer, and they had deployed Mist. At 11 a.m. one day, the Mist Marvis engine reported that they were having issues in their network. The customer's operation teams called their branches, and the branches said, no, there is no problem. Everything is working fine. Mist Marvis engine does not know what it is saying. Okay? At 2 p.m., 6 of the customer locations went down. No Wi-Fi. No network. The Mist Marvis engine was clearly able to point out at 11 a.m. itself that there was an issue going on the network, and it was able to point out that there was an issue on the router, not on the wireless network. The issue was on the router. And then the customer admitted that they had upgraded new code on the router the night before. What was worse? Next day, they were going to upgrade the routers at 2,400 locations. Can you imagine what would have happened to the network? Second is the use case, which is another big organization, global organization, where the Mist system, through artificial intelligence, was able to figure out that the issue was not on a wireless network, the issue was not on WAN, issue was not on a wired network, but the issue was with certificates. How did that happen? At 12:01, the Mist Marvis engine alerted the customer that there is some problem going on in authentication. Digging deeper, it was found out that the customer had installed new certificates to the Windows machine with an expired previous year's date, and hence authentication was failing. So if you look at these two very simple examples of the retailer and the global company, these problems are business impacting. It is very difficult for a human being to start looking at all the things going on this network. But imagine a world with artificial intelligence where this information from the switch, from the router, from the wireless network is being sent to Marvis, the AI engine. And that is able to correlate and understand what is going on with the wireless network. This is why an AI-driven enterprise is critical. An AI-driven enterprise is able to help you understand what is going on with the network and what changes need to be made to make the network more efficient. Also with Juniper, as I'd said, we were acquired as Mist on the 1st of April of 2019. With Juniper, we now have the ability to offer you this full AI-driven enterprise. So, in ending, if you think about it, we spoke about the need for artificial intelligence in network IT. We spoke about two very critical things for the AI engine to work. Number one is data. Number two is compute. So as you look at the future of your enterprise network, I urge you to really start thinking forward for the next decade. The networks you are deploying today were designed 10, 15, 20 years back. Old wine is good. Old networks is not a good thing to do. So, as I'm hoping, as I've given you some thoughts to think about it, the old IT service model, which is being deployed today, was engineered for connectivity. All they cared about is the access point up? Is the switch up? Is the router working or not? That IT services model is dead. The new model is not about the access point or the switch or the router. The new model is whether your experience on the network is good or not good. And hence, to drive that new user experience-based network, an AI-driven enterprise is critical. An AI-driven enterprise is proactive to the problems on the network. It is predictive, and it is self-healing. And for an AI-driven enterprise, you need three simple steps. You need an open and programmable cloud because you need that compute. You need crazy elastic compute to make decisions really quickly. You need AI-driven automation. It cannot just be pure scripting. It has to be AI-driven. We also call it sometimes intelligent automation. And last but not the least, an AI-driven enterprise is optimized for user experience. So I'm hoping that I gave you a new application for artificial intelligence, which is the network itself. And if you want any more details on the artificial intelligence network, as I said before, you can visit the Juniper booth at the exhibition floor. With that, thank you so much for your time today, and I hope you think about how you can use artificial intelligence in your own enterprise networks. Thank you.